So, welcome back to part 2 of Trig on the Fly. Once again, my name is Rob Rolnick, known as Demondo on 3dbuzz.com.
And my name's Heather. Known as Heather on 3dbuzz.
Excellent. So we're going to be continuing with our lesson on trigonometry. In the last part, we dealt with sine, cosine, and tangent of right-angled triangles. Well, the next logical step is to look at sine, cosine, and tangent of non-right-angle triangles, like this one right here. So this is not a right-angled triangle. And we're going to label the sides with, I guess, letters. So A, B, C. And we're going to label the opposite angles with the capitalized form of these same letters. So capital A is opposite to regular A. Capital B is opposite to regular B. And although it looks exactly the same, capital C is opposite to regular C. So what does sine, cosine, and tangent mean for a triangle that's not a right-angled triangle? Well, of course, the right-angled triangle properties have to stay true, because a right-angled triangle is just a very special type of triangle. But even though these new rules are going to be true for right-angled triangles, there's no hypotenuse in a regular triangle. So the right-angled triangle rules don't hold for regular triangles, for any triangle. So we need new definitions. Well, sine of an angle, I'll put question mark, is very simple. All sine, the law of sines for a triangle states that side A divided by sine of the angle A is equal to side B divided by the sine of the angle B, and side C is equal to the sine of the angle C. Does that make sense?
Mm-hmm.
So, I don't happen to have numbers very handy right now, so I'll just grab a calculator. Off camera, obviously. Handheld calculator, not on the computer. And see if I can't, make up some numbers that kind of sort of work. So we want some numbers that will work out in our problem. So I'm just going to make something up, make sure the numbers work out. It will take a second. Okay. So let's say, for example, these numbers aren't the nicest numbers, but they do work, that A is equal to 5, B is equal to 6, and I'll write it over here, capital A is equal to 30 degrees. So far, so good? You gotta say something. Head nods don't come out in the microphone.
Oh, yes.
Excellent. So, what we know is this. We know A divided by sine A is equal to B divided by sine B. So, now we wanted to isolate sine B, because that's what we don't know. Well, that's quite simple. What you do is you say, well, sine B divided by 6, you're flipping both fractions, as a 6, is equal to sine 30 divided by 5. Then you multiply both sides by 6. You have a 6 there, a 6 here now. Those cancel. So 6/5 times sine 30, which will give 6/5 times sine 30 gives 3/5. So I'm just going to put a big arrow and continue up here because I ran out of space. So we know that 3/5 equals sine B. But that doesn't really help all that much because it doesn't tell us what B is, it tells us what sine B is.
Yeah.
So now we need to find B out of sine B. Well, that's where that whole arcsine notation comes. Arcsine of sine of B will give you B. So, in your calculator, I'm just going to do a bit of erasing quickly to get some more space. It'll just take a second. In your calculator, what you'd want is something like to end up with this. Sine, with a little -1, meaning arcsine, of sine of B equals B. Equals B. Now, we don't happen to know what B is. We want to solve for B. But we did know that sine of B, I believe it was 3/5. And if I'm wrong, just say I'm right. So we know that this whole piece here is equal to 3/5. So sine inverse of 3/5 equals B. And by sine inverse, I mean arcsine. So by plugging that into your calculator, as I'm doing now, you'll get something like 36.87 degrees. And there you go. So we know sine of B is 3/5. Plug that into the arcsine command to isolate B, and you're left with 36.87. So to reiterate, the two important things that you should remember from this are as follows. First and foremost, that in any triangle, sine means the following. Sine of an angle divided by the opposite side equals sine of another angle over the opposite side equals sine of the third angle over the opposite side. So far, so good, Heather?
Yep.
Excellent. So that's everything you have to know about sine in any triangle. Oh, wait, I said there were two things, didn't I? Well, the other important thing is really simple. Sine inverse, also known as arcsine, of sine of an angle, I'll put a theta, in triangles will be equal to theta.
Okay.
So there you go. Keep these two things in mind.
Alrighty.
So what's the trigonometric function that is usually covered after sine? Do you know that? What? The one we covered last time in the previous lesson after sine.
Cosine?
Exactly. So now I want to find out what cosine of cosine in a triangle is. Well, cosine looks really complicated. In fact, some people get very confused because there are three formulas to remember for cosine. A squared equals B squared plus C squared minus, you okay?
Mm-hmm.
2BC and then cosine of A. Now what happens if we swapped every single B with an A and every single A with a B in this formula? What would we get? every single A is becoming a B, and every single B is becoming an A. What would the new formula become?
B squared equals A squared plus C squared minus 2 times A times C. Cosine. B.
Right, capital B.
Yeah.
So that's formula 2. You'll notice all we did was we replaced every single A with a B and every single B with an A. Well, the third formula is very similar. You simply replace every single C this time. So, C squared equals A squared plus B squared minus 2AB cosine C.
It's not too bad.
So once again, it's the same formula. If you remember one form, you remember them all.
Mm-hmm.
And once again, you just have to plug in for A, B, and C, and you can solve for cosine of the angle that you don't know. Or you plug in, let's say, the cosine of the angle, and then you can solve for one of the sides. Well, the other thing to remember is that in the same way that arcsine of sine gives you an angle, arccos, so cos with the minus 1, or arccos, of cosine of an angle, say A, equals A in a triangle.
Mm-hmm.
So if I wanted to solve for B, and I had cosine of B, how would I do that? What do you mean? Come on, we just did it. It was the exact same thing I had written out that I just erased. We have a cosine of B, and we want to solve for B. So we have this. And now we want to solve for B. How would we do that?
That formula?
Which was? What did I use to turn cosine of B into B?
I don't remember. I don't know what you're talking
Maybe if you look at a calculator and look at all the pictures of words. Pictures of words. Arcsine of sine gives an angle. We want to do the same thing for cos. Arcsine for sine gives an angle. What's the equivalent for cos? Blank of cos gives an angle. Arcsine of sine gives an angle. Hand gestures, come on! Okay, let's try this again. Arcsine of sine will give you an angle.
Okay.
We want to apply the same concept to cosine. Mm-hmm. So something of cosine gives you an angle.
Yeah.
Okay, I'm going to give you a multiple choice. Arcsine. Arccos.
Arccos?
Arctan. And all of the above. All O above.
It's Arccos.
Yes. Brilliant.
Why don't you just say them?
I was hoping you could, say it. So, arccos of cos of B. In the same way that arc equals B, obviously. In a triangle. So, erase all this. And there we go. So that's one thing that's important to remember. I'm also going to erase everything down here because it's really the same thing written 3 times. Some people prefer to write this formula in a completely unnecessarily complicated way. They say this: A squared minus B squared minus C squared divided by minus 2BC equals cos A. And then they say, well, we don't need all these minus signs lying around because all I did was I brought the B over to the other side, the C over to the other side, and then divided by this whole area to isolate cosine, right? That's all I did. Mm-hmm. You see that?
Yeah.
Excellent. So, and then they say, well, we've got a negative on the denominator. No one really likes that. So they make this a positive, this a positive, this a positive, and the A a negative. And then they say, well, that's really messy, because Dimando can't write for beans. And they rewrite it nice and neatly saying b squared plus c squared minus a squared divided by 2bc equals cosine of a.
It's crazy.
That way you can isolate cosine of a. Personally, I don't like that method.
Yeah.
It's preference. I think, to remember fractions is harder than to just remember an expression. But, like I said, it's preference. If you prefer this way, you're saying the exact same thing as the other way. So all is good. So, do you understand the law of cosine now, which is what we just covered?
Yes, I am good.
So if I would give you values for a, b, c, and cosine of a, and you had the formula in front of you, you could use it.
Yep.
Excellent. So let's do that.
Okay.
Okay. So, here's a triangle.
Alrighty.
And unfortunately, I'm not Zach to do proper voices. So, tough for you guys listening. But hey. Okay. So as I was saying, a squared equals b squared plus c squared minus 2bc cosine of a.
What?
Now, I'm going to erase this angle here because for all I know the angle won't work. C can be, 4. And now we've got a 4, 5, 6 triangle. And that's not a right triangle. So, can you fill in what we know?
Yeah.
What's a squared?
5.
A squared.
10.
A squared.
25.
Right. Fudge, of course, is what you said.
Yeah, why don't you just make it 5 squared?
You could do that. I'm just writing it as we go. But yeah, sure. We can do it in 2 steps if that makes it easier for the viewers and easier for you. So we have 5 squared.
Alrighty.
And then the next line I would say 25.
Alright.
Equals. What's b?
6 squared. 30.
And what's 6 squared?
36.
Plus. What's c? Plus.
4.
What's 4 squared?
16. What?
I said 16. I don't know what you're talking about.
Yes, Demanda is always right.
Exactly. Even when I'm sober.
Sorry.
2, and you said b was 6, c was 4, and we don't know cosine of a.
Mm-hmm.
So minus, 2 times 6 is 12, times 4 is 48. Cosine of a. So now we use a very handy trick that I like to call plugging all the numbers into the calculator.
Very handy indeed.
And we go 25 minus 36 minus 16 divided by negative 48, right?
Mm-hmm.
And do you know why we're doing this?
To get the answer?
Not quite. Since you don't know, I'm going to let you do the work. Here's a calculator.
Alright, here we go.
And we want to find okay, you already said that arc cos of A equals A.
Mm-hmm.
So we need to find a way of getting cosine of A. So that way we can just take arc cos of that. So given this, 25 equals 36 plus 16 minus 48 cos A, you have to find a way to get only cos A. How would you do that?
I have no idea. Plug it in.
Well, go step by step, and I'll tell you as you're going if you're taking the right course of action.
I have no idea what to do. Show me, Demandra.
No. It's important that you can do this for yourself. Because when your teacher comes and asks you, hey, Heather, I hear you're brilliant at trigonometry. And you're like, best in the class. Can you solve this problem on the board? And then you're like, oh no, I have to go in front of the whole class to solve this problem on the board. You'll be all like, thank God Dumano showed me how. Not, thank God Dumano's here to show us how instead. So, Yeah, that's why you have to learn how to do it on your own.
Alright.
So that I can go back home to Montreal soon.
That's right.
So all I did was I rewrote the equation higher up so we have more room to work.
Alrighty.
So, how about we go slowly?
Okay.
Can you combine all of that into one number?
Sure.
And what would that number be?
Let's see. Let me put it in the calculator. $27.
Okay, that works. That does work. So we get 0 equals 27 minus 48 times cosine of A. Now we need to find a way of manipulating this whole line to get only cosine of A. So cosine of A equals, and you don't have to do this in the calculator, you can just give me the numbers and we'll get the fraction afterwards.
Okay.
So what would the fraction be?
Don't know.
Okay, so instead maybe we should do this in 2 steps. How about if we want to get, we have something involving cosine of A and something without cosine of A, right?
Mm-hmm.
How about if we try to get the stuff with cosine of A onto one side of the equation and the stuff without it onto the other? How would we do that? Could we do that?
Yeah, just take it over to the other side.
And what would happen if you did that?
You want to turn positive?
Right. So 48 cosine of A equals 27. Now, how would we get only cosine of A? What can we do? How would we get rid of the 48?
Divide by 27?
Divide by 48.
Oh.
You want to get rid of 48.
Yeah. There.
So the 48 goes away if we divide by it.
Oh, yes.
And we get, make a big arrow, spaghetti type style. Well, head type spaghetti style, put a smiley face in the arrow. Or not a smiley face.
It looks thick.
That looks like evil arrow of evilness equals.
Spaghetti.
And 27 is 3 cubed. I don't think there's a... Does it divide? It might. I'm not going to say it doesn't. It does. Equals 9 divided by 16 is cosine of A. And then you simply plug that into Arccos. So plug that into the calculator and you'll get that cosine of A gives this, and therefore A equals 55.77 degrees. So I guess it's a good thing that I erased A equals 30 degrees, because it didn't quite match up. If your triangle was the same, meaning, and by this I mean if you were using a triangle that you knew worked, so you built a triangle, you knew all the angles, and you knew all the measurements of the sides, then your formulas would give you the same answer for A, and for like the angle at A, or the length of A and all that. The reason you didn't get the same answer here is because I'm making these numbers up as we go, and therefore they don't line up perfectly.
Okay.
But if you were doing a proper problem where everything was planned out ahead of time, it wouldn't matter if you used the law of cosines, or the law of sines, or whatever to solve for your side or angle. You'll get the same answer. It's the beauty of trigonometry. So, we'll erase this, erase everything down here,
Okay.
and now we're going to cover the law of tangents in triangles. So, what was it, 4? The reason I'm not particularly keen on the law of tangents is that it's scary when you first see it. Plus, when you have the law of sines and you have the law of cosines, you're almost never going to need the law of tangents. So, because of that, I'm not going to work out any problems with it. Because you're almost never going to need it. On the rare occasion that you do need it, it's only because the teacher is going to give you a problem. Use the law of tangents to solve. In other words, forced to use it. And in addition to all of this, another reason I'm not going to force you to use it is simply that my numbers don't line up right now. And therefore I'm not sure how exactly it's going to turn out to work. So rather than make you suffer through it all, I'm just going to write it out. So here's the law of tangents. So it has division in it, subtraction, a whole lot of confusing stuff. And as you can imagine, like the law of cosines, you can replace every A with a C or every B with a C and get two other versions of it, all of which are equivalent. They're all saying the same thing. So, this is the law of tangents, and I'm going to erase the triangle and rewrite the other two laws so you have them all on one slide, or one screenshot. That's the tangent law, 10. And once again, you can replace the A's with a C or the B's with a C to get the alternate version of the same thing. Then cosine, as you may recall, is a squared equals b squared plus c squared minus 2bc cosine, that's a times cosine of a. And sine, do you remember what sine was, Heather? The law of sines for any triangle?
Isn't it?
That's cosine, that's tangent.
Yeah.
It had two equal signs in it. It was something equals something equals something.
What? A squared? No.
I'll get you started. How's that?
Alright, that sounds good.
A divided by sine A equals, remember what the other one line was?
B divided by sine B.
Exactly.
And C divided by sine C.
Exactly.
Yeah, there you go.
So here, in any triangle, these hold true. Any triangle. Joy. And now we have to write another word because I've been writing the whole time. What word do you want to write?
Crack.
Crack. Like, this table has a giant crack in it. So anyways, with that, that's going to wrap up this lesson.
Yay.
Thanks a lot, guys.